Thank you, Sarah, for the opportunity to present here today. As some of you may know, I used to live in Southern Illinois, and I attended in person and presented at this event many times. So I'm happy to be able to do it again, even if it's in a virtual format. And today I'm going to be talking about the chemical 6-ppd quinone that so far I haven't heard much about it in the session. Okay, and my keyboard doesn't want to cooperate. Never mind. So which topics I'm going to be covering today? As I mentioned, I'm going to introduce 6-ppd quinone and provide some general information about this chemical. I'm going to present also rapid method that we developed for its analysis using liquid chromatography, mass spectrometry. And then I'll conclude with a couple of take-home messages that you can remember when you close the computer after all the talks. So what's 6-ppd quinone or 6-ppdq? It's a quinone that is formed from the transformation of 6-ppd. And I'm not going to read the full name. It's spelled out in the screen. We know that the 6-ppd, the original compound, is used as an additive and as an antioxidant on tires, on the rubber. And as you can imagine, if you have a car, you're going to have most likely 6-ppd in your tires. But the focus of the talk today is the quinone, the transformation product. And it's been detected in stormwater runoff in several places. There are reports that have been detected the chemical in Australia, in Canada, in the United States. I'm pretty sure every country where researchers start looking for this chemical, it's going to be found. But in general, it's mostly on urban watersheds. And that makes sense because in the urban areas, there is a higher concentration of vehicles, of traffic. If there are more cars, if there are more trucks, buses, whichever vehicle you pick, there are going to be more tires, there are going to be more antioxidants on the tire. So how is this chemical 6-ppd quinone formed and how it makes it to the stormwater runoff? So we need to take a step back and focus on the tire, on the rubber. When we drive our car, we start using the tires, and we are going to generate what they are called tire and road wear particles, or TRWPs. There are several processes that have been reported that are involved in the degradation of the tires. And these could be chemical oxidation processes like thermal oxidation, photooxidation, ozonation. Just the stress, the physical stress from running the tires on the road can also cause the damage and aging of the rubber. And there could be biological degradation processes also. And this is known for decades. The manufacturers of the tires, the material scientists, have been looking into these processes for a long time. And there are even standard methods to test for these processes and to evaluate the results from the aging of the tires. However, as environmental scientists, we always go a little bit behind on understanding some of the industrial processes that are used when manufacturing different goods. And it could be the plastics, it could be products that contain PFAS. There are many examples for this situation. As I mentioned, there are several processes that can be involved in the formation of in the aging and degradation of the tire wear particles and generate the different chemicals. Obviously, once you have the tires on the road and you start using them, thermal oxidation is going to be more relevant while you are driving your car. But once the particles are broken and are formed, and there is rain, and there is the water washing off the particles from the road, and the water becomes the runoff, other processes are going to be more relevant. So the three main processes that are listed in the screen are going to be happening with different degree of impact while the particles are moving from the road to the runoff. When they get in the soils, when they get into the surface water, the different processes, as I said, are going to be more or less relevant in the formation of the different chemicals from the tire wear particles. So 6-ppd quinone has been confirmed. The transformation of 6-ppd to 6-ppd quinone has been confirmed in the lab through ozonation processes. I'm listing in the slides a couple of references if you wanna take a look and understand more the mechanism of formation of the 6-ppd quinone that was first identified in environment, and then in the lab it's been confirmed that it's formed through the ozonation process. But as you can imagine, and I think it was John Scott who mentioned it earlier today, there are many chemicals that are added to the rubber, they are added to the plastics. So 6-ppd is an antioxidant, but there are many others. And even there are more transformation products from 6-ppd that have been identified, different from 6-ppd quinone. There are other compounds that have been identified that are leaching from the tire and road wear particles, and Greg, who will be presenting later, has a very nice publication in which he identified other types of transformation products coming from these particles. And this work has been done mostly by non-target analysis using high-res mass spectrometry instruments. And with these instruments, what you do is like basically you don't know what you are going to have in the sample, so you look for any and every peak feature, any compound that you can find. But why is the attention on 6-ppd quinone? First, because there was a publication at the end of 2021 that demonstrated the direct toxic effect of 6-ppd quinone on the mortality of coho salmon in the Pacific Northwest. And this project was in the making for over 5 years. The researchers, Ed Kolodziej and his team, knew that the coho salmon was dying in the Pacific Northwest, but it took a really long time and a big group of people to really identify who was the culprit of the death of the coho salmon, and they were able to identify that it was 6-ppd quinone and link it to the toxic effect. And after they published the paper in Science, they've also published additional work confirming the toxicity of the chemical. But then there was also another factor, that is the impact of media outlets. And it's something that as scientists, we are dealing with more and more, that the work that we do in the lab, the work that we publish in a peer-reviewed paper is picked by a media outlet, and the relevance of the publication is higher than what it used to be 5-10 years ago, and the public picks on different topics. And I think this has also contributed to a certain extent to the interest in 6-ppd quinone and not in the other transformation products that have been found that are coming from the tire wear particles. So I had a question at the beginning on my slide, opening slide for the presentation. Is 6-ppd quinone a concern on itself, or it's an indicator of a larger problem? And the answer is that we don't know yet. It's very early. The same team that confirmed that 6-ppd quinone was causing the decline in the population in the coho salmon, also found that different species of salmon is not affected by 6-ppd quinone in the same way. So I said, we know that there are some toxic effects. We don't know still the prevalence or the impact of the toxicity in different species and in ecosystems. But also at the same time, we've been talking during the conference that the plastics, microplastics, nanoplastics are everywhere in the environment, and the tire wear particles are kind of related to the micro and nanoplastics contamination. So we know that there are a lot of challenges in analyzing and characterizing those particles. So there is an effort to identify whether we could use other chemicals as surrogates of plastic contamination. And it seems, based on recent research, that three transformation products from 6-ppd could be good indicators because they are stable. The response in the instrumentation that we use to quantify these chemicals is good. So there is still the possibility that 6-ppd quinone, even if we confirm that the toxicity is not doesn't impact negatively across ecosystems, across species, we could still use it as an indicator of the larger problem that is the tire wear contamination.
2 minutes left.
So in the meantime, we need, as I mentioned earlier, most of the work has been done to identify these chemicals using high-res mass spectrometry, but not all the labs can afford to have this instrument. So we developed this quick method using liquid chromatography mass spectrometry to analyze 6-ppd quinone. And this is for those who are less familiar with the instruments in the lab, this is the same instrument that you use to analyze PFAS or cyanotoxins that are coming from algae blooms, pesticides, in general, non-volatile organic contaminants that you find in the environment. So for the work we used the Shimadzu LCMS 8060, we confirmed that the fragments that we were seeing were the same that were published by Ecologists group in the science paper. Here I'm just sharing the general conditions. These are very common conditions that are used in LCMS method. And here I'm showing some of the results that we got from the work. In this case, we have only 6-ppd quinone in the method. And as you can see on the chromatogram on the top right corner of the slide, the compound eluted at 5.5 minutes. I'm showing the gradient in the table in the middle. So we can see that there is still room to shorten the length of the method. If we need to process a lot of samples, we could do this method faster. But also, if we want to add other chemicals to the method, there is room for the compounds to elute there, to be separated from 6-ppd quinone. So we can still modify this method to target the needs in the laboratory. We got excellent results in terms of linearity, accuracy, and reproducibility. And I would like to point out that this method was direct injection method. We didn't do any sample preparation. We didn't have to concentrate. Most of the publications use methods in which you need to concentrate the sample. This was done just getting the sample. If it has a lot of solids, you just need to filter it, and we inject it directly in the instrument. So this method, as I said, is fast, and it gives us the same sensitivity that other methods that have been published with the sample concentration. Because since we didn't concentrate the sample, the 0.01 nanograms per mil that I'm showing in the screen is equivalent to 0.01 microgram per liter.
We're just about at time.
Just one minute?
We're just about at time. Sorry.
Okay. Thank you. So
Yeah, go,
just
yeah,
the-
go right ahead. Oh, you're gonna wrap up? Go right ahead. That's all I'm
Oh.
saying.
Oh, thank you. As I said, we don't know yet if the 6-ppd quinone is it's an contaminant that we should be really concerned about, or it can be an indicator of further problems in the environment. And we developed the method that it's fast and is sensitive enough to give you the results on the environmental concentrations of 6-ppd quinone with just as I said, a very simple method. Filter, inject, and you can get the results. And I would like to thank my colleagues who did the work in the lab,